In order for us to simplify this algebraic expression, we're either going to be using some steps that involve trigonometric identities and doing a substitution, or an algebraic step. When I take a look at what it is that we're trying to simplify here, I see that we have some trig functions that are squared that are being subtracted to or from the number 1. That reminds me that that's probably going to be a Pythagorean identity that we're going to want to use in order to make the substitution happen. Up on the top part of that fraction, we have 1 minus cosine squared. And out of our 3 different Pythagorean identities that we have, the one that has a cosine squared in it is sine squared of our angle plus cosine squared of our angle is equal to 1. So I want to use that Pythagorean identity in order for us to be able to do a substitution. And in order for us to get that to work out, I want to take a look at what we have on the top. If I have sine squared plus cosine squared, I can replace that with the number 1. Or if I have the number 1, I can replace that with sine squared plus cosine squared. In this problem, I do have a 1 here. So using that Pythagorean identity, I'm going to replace the number 1 that I have right here with what 1 is equal to, which is the sine squared of our angle plus the cosine squared of our angle. So in the top part of our fraction, instead of 1 minus the cosine squared, I would have sine squared of our angle plus the cosine squared of our angle, and then we have a minus cosine squared of our angle after that. So this piece right here, that's what that 1 used to equal. In the bottom part of our fraction, I see we have a secant squared of our angle minus 1. So again, I want to take a look at our Pythagorean identities, and we do have one that does have a secant squared in it. So in place of this secant squared that I have here in the bottom part of that fraction, secant squared of our angle is equal to 1 plus the tangent squared of our angle. So I'm going to substitute that in for the secant squared there. So on the bottom, in place of this secant squared, I'm going to have 1 plus the tangent squared of our angle, and then the minus 1 on the end. And again, this piece right here, that is what this secant squared used to be in the previous step. So a couple substitutions there using some Pythagorean identities. And now, if we take a look at the top and see if we can simplify that, in the top I have a sine squared of our angle plus the cosine squared of our angle minus the cosine squared of our angle. So those two cosine squareds would cancel each other out. So in the top part of our fraction, we would just be left with the sine squared of our angle. In the bottom part of the fraction, we have a 1 and also a minus 1. So those 1's would cancel out and would just leave us with a tangent squared of our angle. If I take a look at what we have left after doing a little bit of subtraction and getting some things to cancel, I have sine squared of our angle over the tangent squared of our angle. There's no addition or subtraction here, so I would rewrite this as a multiplication problem and then change things into sines and cosines to finish the problem up. So we have a division problem right now with no addition or subtraction. I'm going to take this tangent squared that's in the bottom, and dividing by anything is the same as multiplying by its reciprocal. So if I move that up to the top and make it sine squared times something, it would have to be the reciprocal of tangent squared. The reciprocal of tangent is the cotangent. So dividing by tangent squared would be the same thing as multiplying by its reciprocal, which is cotangent squared. And now from there, I'm going to rewrite everything with just sines and cosines. The sine squared of our angle is already just with sines, so we don't need to change that one. But the cotangent squared, I want to use one of our quotient identities here. The quotient identity we're going to use is for cotangent. The cotangent of our angle is cosine divided by sine, so the cotangent squared of our angle would be the cosine squared of our angle divided by the sine squared of our angle. So again, I'm taking a look at the cotangent here and using some substitution. I'm going to rewrite that as the cosine squared over the sine squared. That's what this fraction became using that identity. I have a couple fractions being multiplied together here. There's no addition or subtraction, so if we have anything that is in the top that matches anything in the bottom, we can get those to cancel out. So the sine squared in the top of the first fraction will cancel out with the sine squared in the bottom of the second fraction, and that just leaves us with the cosine squared of our angle over 1, or just the cosine squared of our angle. And now we have that in its simplest form.